This is chapter 10 for statistics. We are talking about how do you find a correlation and find the regression equations. This is question 2. Refer to quakes and use the magnitude in Richter scales, MAG, and depth, DEPTH, in kilometer from the earthquakes. So this is a file name called quakes. And then find the best predicted depth of an earthquake with a magnitude of 1.5. So the first question wants you to find the scatter plot and find construct a scatter plot and find the R, linear correlation coefficient, which is R. And then you have to find the p-value. And then after that, use the level of 0.05 to determine whether there's sufficient evidence to support the claim there is a linear correlation between the two variables. And then D, asking you to find the regression equation. And then using the first data, let that first variable will be your x variable. So this is usually what I will want you guys to know here is if I give you this kind of questions, if you want to figure out which is your x, which is your y, which is very important, then the first variable show up, which in this case mag, is your x, and depth will be your y. So it's always like that. And if you switch these two around, your answer for D, E, and F is all going to be wrong. Okay, so make sure you guys know that in this case, mag will be your x, the one that comes first, and that will come second is your y. So this is how you will figure out which is x and which is y here. So this case, x in this case will be your mag, and y in this case will be your depth. Okay, just want to tell you that, very important. And then find the best predicted value and then answer the question if available. So like this question, it does not have answer the question, so you do not need to do that because there's no question here. I just want to point out to you that this is a combination of chapter 10.1 and 10.2. 10.1 will ask you to do A, B, and C, and then 10.2 will ask you to do D and E. So that's the reason why I'm putting all this in A, B, C, D, E in one point so that you can just do this when you do your online homework. The first three is for 10.1 and then the last two is for 10.2. Okay, so so in this case, let's figure out the scatter plot here. So again, we can't find a quake here. So this is the one important thing that you do here is usually we put x equals to read table, so on and so on. You cannot use x equals 2 here. The reason why you cannot use x equals 2 is because x and y, x is reused here for mag. So in this case, we do not want to use x equals 2. So we will use another variable, for example, a equals 2. So those students who are using x equals 2, you will get also error here. So be careful with this. So we will pick a file name called called quake here. So let me see where it is under. It's under here. I know it's under here. It's under apply stats, and I put my book and data. Quick is right here, so it's under quick. And then you so you have all this quick. So we will assign mag for x equals to a, because the variable used here is a now, and is mag all caps. And then y in this case is a depth, all caps. Okay, so now we have x and y. So in order for us to plot this scatter plot, you just do plot x comma y. So this is how you plot your scatter plot. You just do plot x comma y. So this is the scatter plot that we will have. So what I usually do here, because this is your test, if I call you to do this in the test, you just copy here and then you just paste it here. Okay, so it cannot paste in here. So anyway, so in order for you to find this, you just copy and paste it into your test. So you do not need to draw this one out, which is a lot of work here. So do not draw this one out. So I recommend you to copy and then paste it into your homework or your test if you're doing your test here. Okay, so this is a scatter plot that we do. This is part A. So besides scatter plot, the question also wants us to find R. So how do you find R in this case? So using R, your program, so plot xy is draw a scatter plot. So you have to do summary LMYX, this a little tilted sign, and then you have double closing parentheses. So in order for us to find, to do the rest of the information, so you have to do summary LMY tilted X, double closing parentheses. So this is the results that you get. So you get a bunch of things that you will get here. So like what we did here, so you got a bunch of information here. So these are a few numbers that is important. The first one is underestimate. This number is your y-intercept. This is your slope. This negative 0.269 is your test statistic. This 0.7906 is your p-value. So some of you, this question asking for p-value. Sometimes the question asking for test statistic. And then if you look at this 0.004019, this is your r squared. So multiple r squared. So in order for you to find your r here, you have to take the square root of this number. And do not forget that every time when you take a square root of this number, there is a plus or there is a minus. So how do you know what sign to do? Is you check for B1. B1 in this case is your slope. If your slope is negative, then your answer will be negative. If your slope is positive, then your answer will be positive. So it depends on your slope in this case. So that is how we figure out your R, your correlation coefficient. So for this case, my R is this number, 6.234 e to the negative 5. So in order for you to find R in this case is you have to take the square root of 6.234 e to the negative 5. So this R in this case will become 0.0079. This is your correlation coefficient, which is really, really small. So that means that if you look at the scatter plot that we did last time, it is really scattered. You can tell that your plot is really, really scattered. So you can tell, where's my correlation? You can tell the scatter plot that we just have is really scattered because your correlation is so small here, okay? Or in this case, close to 0. So it's actually there's no correlation. B, find the p-value. So where is your p-value in this case? Your p-value is gonna be on here, 0.847. This is your p-value, or it's right over here, 0. So these two numbers are exactly the same. So which is your p-value in this case? So your p-value in this case is 0.847. C in this case is asking us to test the claim whether there is a linear correlation between these two variables. So remember last time when you do your hypothesis testing, you have to write like 6 or 7 steps. So for this case, you do not need to write 6 or 7 steps. You just need to write 3 steps. First, your statement. So your statement in this case is H0, your null hypothesis is, this is not P, this is rho, which is a population linear correlation, is equals to 0. And then H1 in this case will be rho in this case is not equals to 0. So we always do a two-tailed test here. So we don't do less than, we don't do greater than here. So in this case, we always, one is equal, one is not equals to. And in this case, this P is a rho. It stands for population linear correlation. So this is your first step. Second step is you look at your p-value and your alpha. So since your p-value in this case is 0.847, which is greater than your alpha here, which is 0.05. Again, if a question did not give us alpha, we always use 0.05, but this question they give us alpha is 0.05. This is back to your hypothesis testing. Since p-value is greater than your alpha, so we will fail to reject your null hypothesis. And then next we have to do is your conclusion. Your conclusion is very easy. Either you there is a linear correlation or there is not a linear correlation. So how do we figure out this? Is you're looking at your decision here. So if your decision says your p-value is less than alpha, there is a linear correlation. But if your p-value is greater than alpha, you conclude there is no linear correlation. So by looking at this, since the p-value is greater than alpha, so your conclusion in this case is there is not sufficient evidence to conclude there is not sufficient evidence to conclude there is a linear correlation relation between the two variables, between the max and depth. So this is how we write your conclusion, is that is sufficient or not sufficient based on your p-value to conclude there's a linear so in this case it means that there is not a linear correlation between those two. Okay, that's how we do question C here. So this is what you guys do in 10.1. So 10.2 is where you begin to do your regression equation. Where is a regression equation? A regression equation, if you look at your R, it comes from your intercept and your X. So this intercept is your y-intercept and this x is your slope. So this is like back to y equals to mx plus b that you guys learned in your algebra class. But instead of y equals to mx plus b, this is going to be y hat equals to m. Your slope in this case is negative 0.0598x plus your y-intercept, which is 5.9758. Or if you want to write it, you can also write it down as 5.9758 minus 0.0598x. So you can always interchange your slope and your y-intercept around, but make sure that your slope have a variable x next to it. So either one of these is correct. That's how you do this regression equation. And then you have to find the best predicted value. So in order for us to find the best predicted value, usually you plug in the x value. So in this case, the question asking is the magnitude is 1.5. So we know that magnitude here is x. So a lot of students just put x is 1.5 into this equation. You will get it wrong. So the reason why is in order for you to plug it in, you have to check the 3 requirements that we did just now on question 1. First requirement says that your scatter plot shows linearity. So in order for us to figure out your scatter plot shows linearity, you can kind of look at your scatter plot here. So your scatter plot is given us here. I know it's very scattered, but what we need to figure out is this scatter plot shows a parabola? If this scatter plot shows an exponents or logarithm functions, since this scatter plot does not show the nonlinear case, which is the parabola or exponents case, so this one is good. Okay, so that's how you figure out your regression here. Next, you want to figure out that second thing is second requirement here is there is a linear correlation. Unfortunately, this is not good. Why I say the second step is not good is because we already did in part C. What happens in part C, you notice that you already say that is not sufficient. That means this is not a linear correlation. So that is not a linear correlation in this case. So this is no good. So we do not need to do the third step already. We can skip this because this is a bad model. Okay, and what happens to the bad model? We cannot plug in x equals to 1.5 into this equation. You have to find y bar. And how do you find y bar? Here is you type in mean y in your R. So if you type in mean y in your graph in your R, it will give you 5.822. So that is how you find your your prediction here. So since we're predicting this is y, your depth here is in kilometer. So this will be your unit here is in kilometer. So this is how we do this question A, B, C, D, E in chapter 10 here. Again, A, B, C is for 10.1. The last two DE is for 10.2.